Okay, welcome to part 3 of our calorimetry lab. We're going to look at how much energy is released from food and absorbed by water. So this is the same process that happens inside your body. You eat food, your body combusts it, basically, kind of pulls it apart and releases that energy into your system to be utilized by your body. We're going to do something similar with this, only instead of reacting it with kind of the enzymes and the acids inside our body, we're going to combust it. So we'll burn it and see if we can't capture some of the energy that's released by our food when it burns. So we'll do this with an almond. Thank you to Flynn for this setup. It's kind of interesting to look at this with different types of foods, but for today we're just going to get this recorded data with an almond. So the first thing we need is the mass of the almond. Quick reminder on measuring technique: you never want to put anything directly on the scale. You want to make sure something is there to protect your scale from the thing you're measuring. Okay, and our almond is 1.0 grams exactly, so let's write that down. Our almond's mass is 1.0 grams. We're going to try to absorb this energy released by the almond with some water. So we need to know the volume of our water. That's going to be 98.5 milliliters of water. We'll put that into our can. And we also want the temperature of the water in our can. Now again, you want that thermometer to be submerged in the water, but you don't want it to touch the bottom of the can or the sides of the can, because then you're measuring the temperature of the can, not the temperature of the water, or maybe along with the temperature of the water. That's definitely not what we want. Okay, so we'll let that kind of sit a little bit. Now obviously there's going to be a lot of air lost here. We're going to hold our food on this little holder. All right. Okay, so we're going to lose some heat to the atmosphere. The can's going to absorb a little bit of the heat as well. We're measuring the temperature of the water inside the can, so we're hoping that the majority of the heat gets absorbed by the water, but we know there's going to be loss here. However, if you are going to do a comparison with a couple different foods, if you use the same setup with the same air, it gives you a really useful comparison between the different types of food. Okay, so we also want this to be low enough. To touch our flame. Okay, in the water, but not touching the bottom or the sides. All right, so the temperature of our water initially is 21.5 degrees Celsius. And we'll track that as our almond gives off energy. Here we go. Move this around so maybe you can see that flame going. Gonna smell good in here. Okay, let's track that temperature. So it's already up to 31 degrees Celsius. .35 degrees Celsius. .41 degrees Celsius. Love the incomplete combustion you see going on here. Anytime you see black smoke, that means that oxygen is being limited. And so you're getting an incomplete combustion going, which is creating some byproducts. Byproducts of soot, obviously, and also carbon monoxide. All right, temperature is up to 49 degrees Celsius. The burn is still going. Dang, almond. This one's hanging on. The last little flame is flickering over here on this side. Let's see how long it hangs on. Temperature is up to 48 degrees Celsius. And the almond is out. Okay, 48 degrees Celsius. and dropping. So I think that is our maximum temperature. We'll go with 48 degrees, 48.0 degrees Celsius as our final temperature. Part 3.